Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0340, indicates a CMP sensor A no signal error in the Honda Fit model years 2015 to 2020. This code is part of the Powertrain Control Module, PCM, Diagnostics, specifically related to the timing of the engine's operation in accordance with the camshaft position. The camshaft position sensor, CMP, plays a crucial role in ensuring that the engine runs efficiently by sending critical timing information to the PCM. Located near the camshaft, this sensor reads the position and rotation of the camshaft to adjust fuel injection and ignition timing accordingly. A failure or malfunction in this sensor can lead to various engine performance issues, impacting fuel efficiency and overall vehicle operation. The subsequent steps in the troubleshooting process will help pinpoint the exact cause of the error. The CMP sensor is essential for the accurate timing of the engine's valve operations. It detects the position of the camshaft and relays this information to the PCM to ensure optimal fuel and ignition timing. Typically, the CMP sensor is located at the top of the engine near the camshaft, allowing it to monitor changes effectively. When the engine is running, the sensor produces a signal that indicates the camshaft's position. If there's an issue, such as a malfunctioning sensor or poor connection, this signal may cease, leading to a DTC P0340. The PCM relies heavily on the information from this sensor, as it influences various aspects of engine performance, including emissions control and fuel economy. Several factors might cause DTC P0340 to be triggered. The first potential cause is an open wire within the circuit, specifically in the wires connecting to the CMP sensor. This could hinder the sensor's ability to send a signal to the PCM. Another possible cause is a short in the wire connections, which may lead to an incorrect voltage reading. The CMP sensor itself may also be malfunctioning, either due to internal failure or external damage. Moreover, poor connections at the corresponding Powertrain Control Module, PCM terminals, could create a no-signal scenario, further complicating the detection process. Identifying and addressing these issues is pivotal for restoring normal vehicle function. Symptoms associated with DTC P0340 can vary, but commonly include engine misfires, which occur when the timing of fuel injection is inconsistent. This inconsistency can lead to reduced engine performance, such as poor acceleration and erratic idling. Additionally, drivers may notice a decline in fuel efficiency, as the engine may not be operating at its optimal level. Starting issues may also arise, where the engine either struggles to start or doesn't start at all. In some cases, warning lights may illuminate, indicating an urgent need for diagnostic inspection. Recognizing these symptoms early on can prevent further mechanical issues. The first step in troubleshooting the DTC P0340 involves a few key actions. Start by turning the vehicle ignition to the on mode without starting the engine. Then, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs from the vehicle's memory. After clearing the codes, start the engine and observe if DTC P0340 appears as a confirmed fault again or only as a pending one. If the code reappears while the engine is running, it signifies that the failure has been duplicated and indicates a persistent issue with the CMP sensor or its circuit. However, if the code does not appear, it may suggest an intermittent failure that warrants inspections of loose connections or corrosion. In Step 2, attention shifts to verifying the integrity of the circuit related to the CMP sensor. Begin by turning the vehicle to the OS mode to ensure safety during the process. Next, disconnect the 3P connector from the CMP sensor, to isolate it from the system. With the sensor disconnected, switch the vehicle ignition back to the on mode and utilize a multimeter to measure voltage between the designated test points. The measurement should be taken between the CMP sensor connector number 1 and a solid body ground. If battery voltage is detected, it indicates that the cable leading to the CMP sensor is intact. Conversely, no voltage signals an open in the circuit, which requires immediate repair. The third step delves deeper into assessing the wiring associated with the CMP sensor. With the CMP sensor connector still disconnected, you will need to measure the voltage between 2 additional test points, namely CMP sensor connector number 3 and body ground. The vehicle must still be in the on mode. A reading of approximately 5.0 volts signals that the system is functioning correctly at this stage. If the voltage is present, follow up with the next troubleshooting step. However, an absence of the expected voltage suggests further investigation is warranted, as this could indicate an issue either with the TDCAM line or the CMP sensor itself. In this step, focus shifts back to the CMP sensor circuit, specifically the LG line. Again, with the CMP sensor disconnected and vehicle in the on mode, measure the voltage between the CMP sensor connector number 1 and connector number 2. Should you record battery voltage during this test, it confirms that the LG wire is functioning properly and allows for the conclusion that the CMP sensor itself is likely the malfunction. If this voltage is not detected, it signals an open circuit in the LG wire, leading to a break in the connection to component G101. This necessitates further repairs to ensure proper continuity in the circuit. Step 5 involves checking for shorted wires in the TD-CAM line, which is essential for the operation of the CMP sensor. Begin by turning the vehicle to the off mode to ensure safety. Utilize the Honda Diagnostic System, HDS, to jump the SCS line, allowing for a proper check of the circuit integrity. Once this is completed, disconnect the PCM connector B51P to minimize any interference in readings. Measure the continuity between test point 1 at the PCM connector B number 30 and a body ground. If continuity exists, it indicates a short in the TD-CAM wire. Immediate repairs are required at that location. If no continuity is detected, move on to the next troubleshooting step. In the final troubleshooting step, continuity checks are again paramount for the TDCAM line. With all previous connections still in their confirmed status, measure the continuity between test point 1 at PCM connector B, number 30, and test point 2 at CMP sensor connector, number 3. If continuity is established, it implies that TDCAM wiring is functioning correctly. If the PCM software is not updated, proceed to update it to the latest version. Alternatively, if available, replace the PCM with a known good unit and recheck for DTC P0340. If the code disappears after swapping the PCM, it indicates a defective original unit that needs replacement. However, should there still be no continuity, trace the TDCAM wire's integrity for further issues. After implementing necessary repairs, it is crucial to carry out a final verification step. Start by rechecking for any diagnostic trouble codes. Use the HDS to scan for DTC P0340 to confirm whether the fault has been successfully addressed. All electrical connections should be inspected to ensure they are secure and corrosion-free, as previous disconnects can create new issues. Following the clearance of DTCs, start the engine and monitor its performance. Ensure that it is operating smoothly, without misfires or starting issues. If all tests yield no faults, the repair can be considered complete, restoring the vehicle's intended operation. To prevent future occurrences of DTC P0340, regular maintenance checks should be performed on the wiring and connections associated with the CMP sensor. Inspecting these components can catch potential problems before they manifest as DTCs. Electrical connectors should regularly be examined for corrosion, looseness, or other types of damage, which may interfere with proper signal transmission. Additionally, ensuring that the sensor itself is clean is crucial, as dirt and grime can impede its functionality. Undertaking these preventive measures can extend the life of the CMP sensor and enhance overall engine performance. In conclusion, DTC P0340 indicates an important fault concerning the camshaft position sensor's signal to the PCM. Understanding the critical role this component plays in engine management cannot be overstated. It is central to adequate fuel injection and ignition timing. The troubleshooting process, clearly delineated into steps, guides technicians to systematically pinpoint the cause of the error and rectify it effectively. Whether it be a simple wiring issue or a defective sensor unit, following these steps ensures a thorough approach to addressing the trouble code. Adopting preventive maintenance practices further helps in sustaining vehicle performance and avoiding recurrence of such issues. Please like and subscribe to the channel. See you next time.